So my name's Ollie Woodings. I work at a company called Qubit. And for this talk, I want to sort of delve into testing of React. And it's a bit of an ugly area. I mean, testing is pretty boring, right? I bet all of us would choose not to do it if we could. So in here, I want to sort of cover the current space of the React testing environment and sort of where we could take it and where I think it's going to go. So yeah, I'm a front-end developer at Qubit. As a company, we take in tons of web data, about 300 million hits a day. We process it, try and understand it, and then create personal experiences from it. And we do this at scale in real time. We have some clients such as Staples, Emirates, Topshop, people like that. Personally, I work on a product called OpenTag, which is an open source tag manager, so sort of competing with Google Tag Manager. And we're about to release the UI completely rewritten from scratch in React. As a company, we've been working with React for about a year and a half. And during that time, some of our main open source contributions have been in the testing area for React. So first part of this talk, I'm going to go over sort of the evolution, what we did, libraries like Enzyme. So starting from the very beginning, we have the React test utilities. They came with React, I think, when it came out. They're great, they're incredibly powerful, but they're ridiculously verbose, create loads of boilerplate. Nearly everybody will wrap it up in utility functions to make it easier to use. So when React came out, there was not a strong story about how to actually test these things. So you could build these lovely components, build these really fast apps, but you couldn't test them very easily. The first thing we released at Qubit was an implementation of the page objects pattern for React, released by my colleague. And this uses refs, so you put refs on your components, you then pass your render tree into React page objects, and it will then let you navigate it and pick them out. It reduced the boilerplate of the actual tests you're writing, but you then have to implement page objects. So by default, you see here on the left, you've got the actual code in your test, but on the right, you actually then have to write a page object. So it didn't really solve much, it just moved the boilerplate somewhere else. But we recognized that using refs was actually a very nice way to test your components. You could pick out a component very deterministically. You could say, right, this component here, and you can perform assertions on it. So the next library we built was React Test Tree. And this library passes the whole render tree, picks out all the refs, and makes them available in a very simple API. It has none of the boilerplate, it has no page objects, nothing. We ditched all that. And it also has features like stubbing, so you can literally completely not render a component, which is nice if you don't want to trigger the data loading. You can easily provide the context, which was something missing in a lot of other test utilities, and you could very easily mount it into the DOM. Actually, the thing that made it great using refs is its biggest negative. The React team didn't design refs to be used like that. They're actually sort of an escape mechanism, and now they're trying to phase them out completely. The library itself reaches around and messes around with the React internals, so every time React updates, we have to rewrite half of it again, which is not ideal. And just to prove that Facebook really don't want us to use it, this is a pull request into React that makes all the React internals generated with a random ID, so you can't actually find them anymore. So thanks for that. It's great. And this is an example of React Test Tree. It looks relatively similar. On the left, you've got basic usage. We're using a similar syntax to Meetup.js, where you navigate your tree using either get, which gets one level, or get in, where you can get further down the tree. And then on the right, you can see examples of stubbing and context changing. Another library in the space that probably most people won't have heard of is one called Teaspoon. And I found this when researching into testing. Teaspoon is pretty cool. It's jQuery, but for React, and implements a large proportion of the jQuery selectors and the navigation and filtering, etc. It's got a nice API. It's very extendable. It has a huge range of selectors. And you can also support shallow rendering. For anyone who doesn't know, shallow rendering is where you take the components, but you only render the top level. You don't render any subcomponents. Unfortunately, it's not had a big uptake. It's been around for a while, but hasn't got many stars on GitHub yet. It might take off in the future, but I'm not sure, to be honest. A new addition that came out recently, people might have seen this floating around, is expect.jsx. This isn't really a framework, it's just a utility method. So expect.jsx allows you to compare the output of a React, or any JS exponents, doesn't have to be React components, and allows you to compare it doing like an equality check. It's very useful, actually, and there's versions for Chai and other assertion libraries. But as I said, it's not really like a library or framework, it's just utility, but I think it's worth mentioning. So Enzyme, I'm pretty sure most people in this room will now have heard of. It's really much blown up. 2.5K stars on GitHub. Airbnb have produced this, and I think it's a great step in the right direction. The community has really started to get behind it. It's very similar to Teaspoon, actually. They both are sort of jQuery replicas. It has the advantage of over test tree, you don't have to add refs on everything. And it has a very clean API with some jQuery selectors. The selectors are actually a bit limited right now. They don't have anything like has or nth child, things like that, which are actually quite useful. But that is in one of their things to work on and improve. It's also an absolute pain if you don't want to run it in Node. If you want to run it in the browser, you have to stub out JS DOM, Cheerio, loads of other modules. It can be done, but it really isn't designed for that purpose yet. So I'm hoping to see them develop in that area a little. So the testing triangle, a pretty boring subject again. If anyone doesn't know what the testing triangle is, it's the idea that you have unit tests at the bottom. You write lots of unit tests. You have functional tests above it. You write slightly less of them. They work between your modules, testing small integrations. And then at the top, you have end-to-end testing, which is the user, what the user does on that. And for that, you don't need to write many, but they should be very concise and designed around user flows. Just a quick show of hands. So who writes unit tests? I hope to see everyone's hands. Functional testing, end-to-end or web automation. Cool. So distinctly less hands as we went on there. So here I've created a Venn diagram. And added some Pulp Fiction. And it shows where the libraries, the testing libraries built for React, where they fit in into this kind of area. Now, nothing in the React area is really written for functional. Nobody writes a library and goes, oh, this is functional programming. But you can use Enzyme and Teaspoon for that. And as you can see, there's literally nothing in end-to-end. We're not writing, nobody in the community is writing things to help you with end-to-end testing of React applications. And so when I realized this, I thought, well, why? Why are we doing this? And really, because, end-to-end tests are very important, right? As you can see here, this had 2 unit tests and no functional tests. Someone came and made 2 doors, windows, checked they opened, they didn't check that they opened together. That's why end-to-end tests are really important. They can pick out bugs that your users will find when they're using your system as a whole, instead of very small things. So why? Why are we ignoring end-to-end testing? Well, if you look at any of the major web automation libraries, WebDriver, everything built on top of Selenium WebDriver, it says in their manifestos, oh, we designed this to be framework indifferent. We don't care what framework you can use, React, Angular, God forbid. And it doesn't matter, they don't care. And they tout that as a good thing. So it's kind of understandable that people don't build anything else when all the major players are saying, no, you don't want to do that. Also, things like Selenium are an absolute bastard to run. Like, you have to download Java, and you have to download all the Selenium standalone, you have to have the browsers, everything. It can be a right pain if you just want to get running on Selenium. It's not fast at all. Also, the APIs with these Selenium drivers, Selenium tools are often quite archaic. They don't embrace modern JavaScript. The only one, I think, is WebDriver that embraces yield, things like that. Generally, it's just not easy to work with, and it puts people off. But actually, this framework indifference that these people have is very negative. It can be very negative. Anyone who's worked web automations will know that they constantly throw false negatives. To give an example of why that is, say that I want to click on a button, and that causes some data loading or a page reload. Now, in my web automation test, I need to decide, okay, how long do I wait for that automation test to pass, or when should I assume it fails? And if you don't know anything about the actual application, you just have to pick some arbitrary amount of time, like 5 seconds, and assume that after 5 seconds it's failed. Well, if you've got a slow internet connection, what if it takes 6 seconds? You're then a bit screwed. And there really isn't any way to solve this without starting to acknowledge the underlying framework being used. But we do have to remember that it is a positive thing as well. So not having your end-to-end tests rely on a framework makes them more user-like. It's more like what the user would do. They wouldn't sort of look at an action, wait for a Redux action to come along saying the data was loaded. They would just sit there, look at the spinning wheel, and wait until it doesn't work. And also, end-to-end tests survive over code refactors and framework changes. If the front-end UI doesn't change, then you can rewrite that, rewrite the underlying stuff, and your test will still work. But could there potentially be some kind of middle ground? So I want to sort of throw around the idea of maybe we could build some kind of smarter web automation system. Let's build it on top of Selenium WebDriver as a base, because that works, it's great, it's really nice to work with. And all we're going to use it for, we're not going to use its primary APIs. Instead, we're going to use it as a way to just inject code into any browser we want. And then this code we inject will be built out of small plugins. So say we wanted to, in our API, we wanted to be able to select things on the page based on what type of React component they are. Then let's inject Teaspoon or Enzyme into the page. Or say we want to do quality checks, let's use expect.jsx. Or navigate around, let's write something for React Router that allows you to trigger navigations on the page using React Router itself rather than having to do hash changes or things like that. And then, obviously, for actions, you'd have something like Redux integrations. So if we think about kind of the requirements from a sort of developer point of view here, and these are out of order, so ignore that. So developers need to be able to use this in an efficient manner. It needs to be simple, fast, and reliable to use. The biggest pains that we often get around testing of any sort now is that it can be slow. You run in Karma and you add on like 500 unit tests, and it can take ages to get through all those. And it's interesting, actually, at Qubit, we've been experimenting with, when we're developing, we don't use Karma. We run everything inside Node with JS DOM. And our testing on the app that I've been working on, we've sort of been seeing Karma taking 15 to 30 seconds to run, whereas JS DOM running the tests will take, with just pure Mocha, will take maybe 100 milliseconds to run 300 tests. So that kind of thing is what I think is very important for whatever we build in the future with testing, is that it's fast at scale. The API as well needs to be modern. It needs to embrace, we've got Babel now. We can build with these incredible new features whenever we want. The APIs that we now design for these kind of things should embrace that. So using async await is the perfect companion for automation tests, where you need to wait arbitrary amount of time for something to complete. And the number one thing that annoys me about a lot of the existing automation frameworks is they force you to use their test runner. So they force you to use Jasmine or Mocha or QNet. They are specifically written for that. I don't see why. We should be able to choose which one we prefer in our dev team. We shouldn't be forced into that. So I've been working on a proof of concept for what this kind of could look like, and I've called it React Driver. It lets you write context-aware web automation. So it lets you directly interface with React or whatever you want to work with. It can also download and run Selenium for you automatically on a computer with no configuration or anything. It doesn't care what runner or framework you use, and also it can be zero config. So to just run it, it just runs on its own. You can add config, but that's optional. It's currently proof of concept, it doesn't work yet. I'm still working on that. But a functional release should be coming out soon. So actually, how would you go about using React Driver? So the first step, you include a tiny registration module in your actual application. And this is just so that we can link back into the testing framework and actually communicate with the React application. The second step, you write your automations using our new API we've designed. So it's designed to be very functional and work well with modern ES6, ES7 features, making extensive use of async await. Here you can see integrations with Enzyme, Redux, and React Router. So we can do things like wait for a specific action to occur, whereas normally you would have to wait for an arbitrary amount of time and hope it was there, or poll for an element on the page. We can now wait for a specific action to be emitted, which is deterministic. We know that that will either happen or it won't happen. If it doesn't happen, then we can throw an error and say it failed. And then finally, we have a command line wrapper. So here you see I'm running it with Mocha. The React driver application, all it does is spin up Selenium for you if you need to, and then it sets some environment variables, so when your tests run, it's able to know which browser to communicate with. As you see, it's lightning fast. This is running locally in Chrome and Firefox using WebDriver as a base, and it's looking very promising at the moment. So the final thing I kind of want to talk about is outside of that, outside of React driver and what I sort of are working on right now, where else is React testing heading? The React team themselves still don't have a perfect story on how they want React components to be tested, and they've admitted this themselves. So where do I think it's going? Well, Enzyme is taking off. Right, Social Proof is saying, we've got loads of stars on GitHub, loads of downloads. This is kind of what the community is getting behind right now. And I think for a long time we'll see Enzyme rising more and dominating it. I'm also impressed by their future development ideas. They've got plenty in the pipeline. I don't think it's going to stagnate, and I think they'll keep working. Unfortunately, I don't think Teaspoon is going to take off because of Enzyme. Enzyme is so similar that I think it's just kind of knocked it out of the way. Even though Teaspoon came first, Enzyme, they've got the power of Airbnb behind them. They're really pushing it. So if I was to put my money on anything, it'd be Enzyme at the moment. The next thing I want to talk about is something a bit more abstract. It's generative testing, which is an idea that's come from more functional languages like Haskell. And it's the idea that you can generate the inputs for your tests, any input, and then you should be able to perform assertions on that. And that only works if something is very functional and doesn't have its own state inside. Luckily, React components have been excelling in that area. So we recently saw the release of stateless components, where you don't have any state in a component at all. It's a pure function. So my hypothesis really is if a component is perfectly functional, like a stateless component, and its props are perfectly described with prop types, we could theoretically generate a set of possible inputs and outputs and then deterministically make sure that they match up. And I think this could potentially be somewhere where we could sell in this. You can use something like expect.jsx to assert that the generated output is equal to the input as well. This will allow your tests to become much dumber. So instead of having to write logic for working out how to test your component, you're just writing something that says how to generate the props for that component, and it will do the rest of the work for you. The difficult part of this, though, is that generative testing requires you to be able to assert that an output is correct given a randomly arbitrarily generated input. And this is not easy to do, right? A big component with maybe 15 different props, and you're going to look at lots of combinations of different props there. If you're just using pure generative testing, you'll need to know the output of all of those different ones. So I think, what if we look to regression testing? So for anyone who doesn't know what regression testing is, that's where you're looking to see if when you change something, you've broken something else, or whether you've broken a previous piece of functionality. And to do that, you need to be testing against a known acceptable state. So my idea around this is you implement your component, first of all, just from scratch. It doesn't have any tests or anything. You make sure it works. Make sure it's all working, and then you can generate an initial output of all those components, which you call your test spec, and you generate that off your props, and that is a known output that you know to be valid. Now let's say you come further down the line and you update that component. You can then run those tests again, and you have the known output already, and the input is automatically generated, so when you update it, you don't have to do anything. It just tells you what's broken instantly. And then you can just say, if something breaks, you can say whether it's a valid break, i.e. I wanted to change that to this new value, or you can go ahead and fix the problem. This is not an easy thing to do. I don't know, anyone who's done visual regression testing knows that it's really, really difficult. It's a pain in the arse. Traditionally, it's done with screenshots. So you take a screenshot of a component, then change something, screenshot it again, and diff it. Problem with that is you have minute pixel differences, which might be acceptable to you, but is actually invalid and will throw an error. But actually, we can get around that by we're not going to be using screenshots here. We're going to be comparing JSX output, which we can actually compare, and we can say definitively, this is not the same as this. But it's still, it's still hard to implement. We've got to do things like, where do you store these test specs? Do you keep them in the repo? How do you sort of easily and quickly say, okay, this thing that's now broken is actually not broken and I want that as a new state? There needs to be some kind of really easy-to-use command line interface around it. And one of the biggest things is, while you're generating these inputs into these props to go into a component, how much do you generate? How many variants do you do? How do you control what is generated? If you just give an algorithm free rein over it, it'll generate you millions of different types of inputs. So you need to be able to constrain that. But I think it's a very interesting area, and something that hopefully I'd like to start experimenting with later on this year and see whether something like this could work, because I feel it could make testing React components very simple and very easy to use. And yeah, we're hiring. So, thank you very much.
Thanks, Ollie. It's really good. Really interesting. Does anybody have any questions for Ollie?
Hi, thanks for the talk.
Speak close.
Okay. I guess I want to challenge the idea that a good end-to-end test has to wait an arbitrary amount of time for interactions to be responded to,
Sure.
since I guess what you're really testing here is that the user gets the experience that they want or expect. So you decide how long the user should wait for the button to respond, and you put that into your test.
That's a very valid point. I'd say that you can't control there's some things you might be testing. You're not testing the speed of the network you're running over. So if you're being slowed down by some slow network on your server, the end user might not ever experience that, because this could just be a development server. So you can still get false negatives. And realistically, when you're working with end-to-end tests, getting any kind of false negative is annoying, because you have to stop. You have to come out of your current flow and work out why this is failing, and it might just be because of some slow network request on the server. So that's...
Sure, that makes sense, yeah. So I guess that's why you should make sure your test environment is as close to the actual user's end environment as possible.
But yeah, you can't control all those variables reliably all the time. So.
Sure.
Hi there.
Hi.
When you inject your stuff into the page, do you ever worry that that's going to affect the test because everything's in one?
I haven't actually done any performance tests around that yet, but the fact that you don't actually run any tests until the code's been injected and evaluated and run, I don't think it would, especially since the kind of code we're talking about injecting, we're not injecting hundreds of kilobytes of code, we're injecting small things in isolation. So and all the code being injected will be sandboxed as well. It's sort of wrapped up in an anonymous function.
Right.
It can't affect the global state of the page.
Okay. Cool. Thanks.
Anyone else? No. Good. Thank you, Ollie. Cool. Right, we're going to take a break for 5 minutes. Go and get a beer. It'll be more like 10 probably, but get a beer, and then we've got Jonas and Michael Jackson.